All right. Before you get here to some example problems and notes, so to speak, make sure you've watched those YouTube videos. They give some excellent visuals of what cross sections and stuff are, way better than I can ever draw. So cross sections, we're trying to figure out what is made if I take a three-dimensional figure and I slice it horizontally, meaning parallel to my base, or if I do it vertically, meaning perpendicular to my base. So make sure you watch those videos. They're mostly short, but just giving you way better visuals than I ever could about what a cross section is. So now we're going to go through and we're going to do some examples. So how can we identify the geometric cross section of a 3D figure and determine the rotational image of a 2D figure? So cross section, a surface or shape that would be exposed by making a straight cut through something, especially at right angles to an axis. So we have our initial picture, got our cylinder. I can do a cross section parallel to the base, creating this circle shape here. So we're kind of using our imagination that I'm cutting that horizontally, meaning parallel to the base. Or I can cut it straight up and down, and that means it would be perpendicular to the base. So this one's parallel and this one's perpendicular. So we're going to go through and we're going to do some examples. Again, make sure you watch those videos. They give excellent visuals to what a cross section is. Example 1. What is the vertical cross section going through the center of this figure? So I'm doing it vertically, meaning I'm doing it perpendicular to the base. I am not the best drawer, but here I am going to attempt to draw this picture in here. So I'm doing vertical to the base. So you kind of imagine like a sheet of paper or something vertically through the base. Again, I am not the best picture. We're using our imagination that I am slicing this vertically. So what is the vertical cross section going through the center of the figure shown below? It is going to make a triangle. So I have this prism. I'm going to cut it straight through the middle, up and down, and it's going to make a triangle. Okay. Example 2. Daniel cut the corner off a cube as shown in the diagram below. Points A, B, and C are the midpoints of the edges of the cube. What type of three-dimensional figure has been cut off? So my options are a cone, a cube, a triangular prism, or a triangular pyramid. I can eliminate the cone just because I don't have anything circular in here. I can eliminate a cube because my basic shape here is a triangle. So my options are a prism or a triangular pyramid. Since it says that points A, B, and C are the midpoints of the edges of the cube, I can imagine them all leading up together like so. So this makes a triangular pyramid. So the answer is D. So lots of visuals in here. Again, watch those videos. I know I keep referring back to those, but it'll kind of give you like a sight, like visual to what we're doing here. Example 3. A right circular cone is represented by the drawing below. Which figure could not be a cross section of a right circular cone? So which one is not going to work? So if I cut it parallel to the base or if I cut it vertically to the base, which shape is not going to be made? So I know if I do horizontal, so parallel to the base, I'm going to create some sort of circle or oval. So that's going to be A or B. If I cut it straight through the middle, up and down, it's going to make a triangle shape. So that leaves C, because a cone is like so to speak, like a upside down, like triangle, so to speak, with a circle on top. So it's going to make a triangle. So the only cross section that is not going to be made, again, it says not, is D. Example 4. What three-dimensional figure do you get when you rotate a rectangle 360 degrees? I believe this was in one of the videos. So if I take a rectangle, rotate it 360 degrees. So take a sheet of paper, rotate it all the way around, hold it vertically, rotate it all the way around. What kind of shape is going to be made? It's going to be a cylinder. And last but not least, example 5. Kathleen rotated an isosceles trapezoid 360 degrees around the longest base. Which choice could be the resulting solid? So an isosceles trapezoid. Isosceles means that two sides are the same. Okay. So this is a trapezoid and it's isosceles because my two bases, my two legs there are the same. We're going to rotate this 360 degrees around the longest base. This is the longest base, so I'm rotating around that right there. Which choice could be the resulting solid? You should get C. So if I'm rotating along this base here, when you rotate around, think back to example 4, how we took the rectangle, we rotated around and made a circular, like cylinder thing in there. So I'm going to have something circular in there. Since it's not going to be this because all the sides are not the same. And it's not going to be this one because I don't have anything circular. So I'm not considering the rotational part of it. So it's going to be this one because I'm rotating along the longest side. So the answer to that is C. Again, one more time before I end the video, make sure you watch those YouTube videos that I've linked here because they give excellent visuals to what a cross section is.